طيب معنا exercise for all the students here. معنا exercise يقول internal energy, work heat with change of state. So, first question, let's say 1 meter cube of air assimilated to perfect gas, the ideal gas, at a pressure of P1 10 bar. Pressure, the first pressure هي 10 bar, undergoes an expansion at a constant temperature. يعني في expansion, وهذه expansion معناته الvolume will increase. At a constant temperature means no change in the temperature from first and final. The final pressure is P1, which is equal to 1 bar. The main question is, determine the work and heat transfer exchanged by the gas with the outside environment during this expansion. So, if we want to find the work first, data, given data here, ايش معنا؟ معنا V1 equals to 1 meter cube. 1 meter cube. For a pressure, P1 equals to 10 bar. Here you have 10 bar. حتى يكون واضح 10 bar. البار طبعا يتغير 10 to the power of 5 after في الكالكولس. Will V2 unknown till now, but the pressure P2 it comes 1 bar. 1 bar. Expansion at a constant temperature. What does it mean this? When we see expansion at a constant temperature, expansion at a constant temperature, this automatically means isothermal process. It's an isothermal process of expansion. So isothermal process. Isothermal process. Isothermal process means what? The change in temperature هذا delta T. أنا أتكلم معاكم على أساس تفهموا أوضح. Delta T equals to 0. And never forget that pressure multiply volume in this kind of process is a constant. It means P1 V1 is equal to P2 V2 for the same constant. We try to find, first question, the work. The work in such process is minus integration of P dV, because this process should be slow, and the work here is a path function. It's not a state function, it's just path function, so we have to use the path from V1 until V2. We change, and why we change this? Because the pressure PV is equal to nRT for the perfect gas, and sure P1 V1 is equal to P2 V2. P2 V2. First we use PV nRT, so we change P with nRT divided by V. So it comes minus nRT, two constants, so temperature is constant, so outside the integration, still the integration of respect to the volume V, dV over V. So here we have changed P by nRT over V, and this from V1 to V2. The work comes equal to minus nRT ln the logarithm of V2 over V1. Rules of logarithm, log A over B, minus log B over A. The minus can be entered in the log, and it comes nRT ln V1 over V2. All right. But we haven't any data for the number of moles and temperature. We change nRT with P1 V1 or P2 V2. So it comes here P1 V1 instead of nRT, because P1 V1 is equal to P2 V2 is equal to this constant nRT. So P1 V1 ln V1 over V2, or you can write P2 V2 ln V1 over V2. So you see here, you cannot find the work if you don't have a V2. If we don't have a V2. By the reason, as P1 V1 is equal to P2 V2, because of the process قلت من البداية isothermal process. You can extract V2, and V2 comes P1 V1 over P2. All is there. P1 10 bars, it means 10 multiplied by 10 to the power of 5 in Pascal. Multiply V1, which is 1 meter cube, correct, over P2, which is equal to 10 to the power of 5, 1 bar. P2 is 1 bar. This calculus gives 10 meter cubes. You have found the volume V2, so you complete it. So you can now find the work, which is equal P1 V1 10 to the power of 6 altogether, 10 multiply 10 to the power of 5, 10 power 6, ln of what? Of V1, which is equal to 1 over V2, which is equal to 10 meter cube. واضحة، مفيش مشاكل في الunits. In this calculus you will find minus 2.3 10 to the power of 6 joules, or megajoules if you want. So this is the work which is negative, so extracted from the gas to the environment, or let's say to the exterior medium. هذا السؤال الأول. We need now the exchange of heat، معناته ال Q. So the Q, we know that a change in internal energy is always equal the work plus the Q, plus the heat Q. Or another thing, if it's isothermal, the change in the internal energy, which is always equal to n number of moles, CV, the constant of capacity at a constant volume, found in a constant volume, multiplied by the change in temperature, all we know that in the isothermal delta T is equal to 0. So this delta U, I mean the change in the internal energy, is equal to 0. That's why we can say that this one, or this quantity, is equal to 0. Then work plus the change in heat equals to 0 means the change in heat Q is equal to minus work. Minus work, just you change the sign of the work. 2.3, not minus, 10 to the power of 6 joules. In this expansion, the system gives off a work and absorbs heat. So it absorbs heat because it's positive and gives off a work to the exterior medium. Thank you for watching.